Dear friends, book lovers, w- dear friends, book lovers, hi, I'm so happy to be with you again and reading from my favorite book, Tao Science book, written by uh, Master Shah, Dr. Master Shah, and Dr. and Master Ruling. She is a quantum physicist. And on the page 14, classical physics. So I would read from this part on as, and it says, the rediscovery and development of optics in 17th century Europe led to more accurate measurement of movement of heavenly bodies, especially the movement of the planets in the solar system. Mathematical relationships explaining planetary motions were discovered. The renowned British scientist and the mathematician Isaac Newton from 1642 to 1726 he proposed a gravitational force between the sun and the planets. This force was what led the planets in their positions. Newton also presented the three laws of motion. Newton's three laws of motion tell us that everything tends to remain at rest or move in one direction at a constant pace when left undisturbed. This property is called inertia. Therefore, inertia is resistance to movement. Force is needed to make an object move in a different direction or at a faster or a slower speed. Mass is the physical quantity that measures the inertia of everything and everyone. The more mass you have, the greater force is needed to move you. For every uh, for every force you exert on others, the exact same force will be exerted on you. With the introduction of gravity and the three laws of motion, Newton could derive the mathematical formula governing motion of planets. As Newton was sitting under an apple tree, a falling apple hit him on the head. This gave him an aha moment. He was awakened to the universality of gravity. Gravity is not only the force that holds the sun, Earth, and the other planets together in space, but is also force that holds everyone and everything on Mother Earth. The apple falls back to the ground instead of falling away to the sky because of the gravity of Mother Earth. When we jump up, we come right back to the ground because the force of Earth's gravity pulls us back. Gravity is a force existing between everyone and everything. This force is proportional to our mass. The more mass you have, the more gravitational force you exert on others. The gravitational force between you and me is negligible compared to other forces that affects us because our masses is small. Mother Earth has a far greater mass. When we can, sorry, we can We can all feel Earth's gravity pull. Our weight is the measure of the Earth's gravitational force upon us. When you move to a higher altitude or to other space, you weigh less because Earth's gravitational force uh, uh, on you is reduced. On the moon, your weight automatically would be about one-sixth of your weight on Earth, even though your mass remains the same. Optics studies the movement of light. Progress in optics had helped to create more powerful telescope, microscope, fiber optics, laser, and many other brilliant discoveries. Classical thermodynamics studies how pressure and temperature affect the movement of matter and energy. Thermodynamics consists of four thermodynamics laws. These discoveries are expressed in mathematical formulas called equation of state. The zero, uh, the zeroth law of thermodynamics tells us that when we bring two systems together and leave them alone, they will eventually reach an equilibrium and have the same temperature. This implies the temperature is a universal physical quantity to describe the state of everyone and everything. Because of the zeroth law, we know we can use thermometer to measure temperature and compare temperatures. The first law of thermodynamics introduces the concept of energy into physics. It express uh, it expresses oh, I'm lost. It expresses the law of conservation of energy. It tells us that everything has internal energy. You can change the internal energy by doing work, such as lifting a weight or exchanging heat. You can also use the internal energy to do work or give heat. Energy can transform into different forms. It can also be transferred into another location. However, the total energy remains the same. The law of conservation of energy tells us that energy cannot be created or destroyed. The second law of thermodynamics tells us that cannot uh, that uh, the heat cannot spontaneously flow from a colder place to a hotter one. It introduces entropy as a physical quantity to describe the state of everyone and everything. Entropy measures the disorder within a system. Usually, the hotter the system, the more disorder it has. Therefore, a system with a higher temperature has a greater entropy, uh, than one with a lower temperature. Heat is the energy related to entropy. The second law of thermodynamics tells us that if left alone, a system will always become more disorder. Is uh, is entropy that will increase and eventually reach a maximum. The second law of thermodynamics presents a phenomenon of irreversibility in nature. For example, if you don't put any effort into putting order into your room, it will become more and more disorder. It will not get neater by itself. Its entropy will increase. The third law of thermodynamics tells us that as we lower the temperature of system, its entropy gets smaller and reaches a minimum as a temperature approaches absolute zero. Electromagnetism studies the movement of everything under the electromagnetic force. Developed over the course of 19th century, classical electromagnetism culminated in a work of James Clerk Maxwell. Maxwell unified proceeding development in electromagnetism via the set of equation now known as Maxwell equations. Through these equations, people discovered that light is an electromagnetic wave. The development of electromagnetism has led to the invention and the use of electric lights, electric tools and machines, the telegraph, and in many other applications. For physicists used to Newtonian mechanics, electromagnetism appears to be peculiar. In fact, is not consistent with classical mechanics. According to Maxwell equation, the speed of light in a vacuum is a universal constant. This violates the assumption in Newtonian mechanics that all laws of motion are identical in all inertia frames of reference under Galilean transformation. An inertial frame of reference is a frame of reference that describes time and space homogeneously, and in a time independent and a space independent manner. A Galilean transformation treats space and time as separate identities. The assumption that space and time are independent of each other was a long-standing cornerstone of classical mechanics. Modern physics. The early 20th century ushered in many new beginnings and dramatic changes for physics. The discoveries in physics started to challenge classical physics. New ideas and concepts have been introduced. Modern physics, which includes relativity theory and quantum physics, started to take shape. Relativity theory. To reconcile electromagnetism and classical mechanics, Albert Einstein introduced a special relativity. A defined feature of a special relativity is the replacement of Galilean transformation of Newtonian mechanics with the Lorentz transformation. In the Lorentz transformation, time and space are connected. A change in time will lead to change in space, and vice versa. Space and time are interwoven into a single continuum known as a space-time. The interconnection between space and time yields the famous equivalence formula of mass and energy. E equals mc2 squared. A special relativity theory makes a classical mechanics compatible with classical electromagnetism. Classical mechanics is a special case of special relativity theory when the speed of moving object is much smaller than the speed of light. A special relativity further shows that in a moving frame of reference, a magnetic field transforms to a field with a non-zero electrical component and vice versa. This reveals that the electrical and the magnetic forces are just two different aspects of one force, electromagnetism. This great discovery of the oneness of the electrical force and the magnetic force inspired Einstein. He has spent much of his later years to continue this process of unifying forces by trying to unify the electromagnetic force with gravity. He did not live to see this effort come to fruition. To this day, unifying the electromagnetic force with gravity is an important ongoing pursuit in physics. A special relativity theory is limited to flat space-time. To address a curved space-time, wherein space-time is curved and bent by mass and energy, Einstein created general relativity theory. General relativity is the theory about the relationship among matter, gravity, and space-time. It describes how matter determines space-time and how space-time directs the movement of matter. Einstein's theory has important astrophysical implication. For example, it implies the existence of black holes, regions of space in which space and time are distorted in such a way that nothing, not even light, can escape. It demonstrates that a black hole is an end state for massive stars. General relativity is also basis of current model of expanding universe. As if Einstein relativity theory did not shake up classical physics enough, quantum physics dramatically challenges classical physics and the foundation of all natural science at its deepest core concept and principles. Quantum physics, now we are talking about quantum physics. Quantum physics studies that everything and everyone are made of and how they behave at the macroscopic level. When physicists explore the world at the smaller and the smaller space-time scales, or at higher and higher energy level, they enter the quantum world. Studies in the quantum physics indicate that everything is made of various vibration, also called waves. A vibration or waves is a periodic oscillation because quantum vibrations are not limited by space and time. Everything uh, basically, a vibrational field consisting of different vibrations. A vibrational field is described mathematically by the wave function. A wave function is a mathematical formula that expresses the type and quantities of vibrations or waves within a system. Quantum physics challenge the foundation of physics and natural science at its deepest core in three ways. First, quantum physics is fundamentally non deterministic. In quantum physics, everything is described by wave function, which can only tell us the chance that certain things will happen. Because of the probabilistic nature of quantum physics, some scientists, including Albert Einstein, have been reluctant to accept quantum physics as the fundamental physics theory. The measurement problem in quantum physics involves the debate about why our world appears to be definite, while underlying quantum nature is the superposition of many possible vibrational states. The main issue posed by the measurement problem is how observed reality is manifested from the vibrational field, which contains many possible states described by the wave function. Second, the concept of quantum phenomena drastically conflicts with one of the cornerstones of natural science and scientific research, which is objectivity. It is generally accepted in natural science that natural phenomena are objective. The, their existence doesn't depend on the action of the observer. In quantum physics, however, the phenomena are subjective and depends on the action of the observer. Third, some quantum phenomena, such as quantum entanglement or quantum correlation, uh, correlation challenge our concept of space and time. Two or more quantum waves can be quantum entangled when they are created from the same source. For quantum entangled vibrations, if you do something to one of them, the other will be affected instantly and transformed to the state that is determined by the quantum entanglement, no matter how far apart they are. This non-local effect is beyond the normal conception and perception of time and space. Albert Einstein called these quantum phenomena a mysterious, in quotation, a mysterious action at a distance, unquote. These non-local effects contradict the limitation of transmission of information in Einstein's theory of relativity. These three distinguished qualities of phenomenon physics have caused many scientists to question whether quantum physics is a complete or correct theory about reality. Many interpretations have been proposed to make sense of quantum physics, such as Copenhagen interpretation, pilot wave theory, collapse theory, many worlds interpretation, and more. Interpretation of quantum mechanics are attempts to comprehend quantum physics in terms of our ordinary understanding, as well as in philosophical and metaphysical terms. The generally accepted Copenhagen interpretation of quantum physics discarded the idea of objectivity of physical reality. It suggests that physics is a subjective discipline that deals with only our knowledge of physical reality. Pilot wave theory is also called the Bohm theory. I hope I pronounced it correctly. Bohm theory or causal interpretation. It maintains the deterministic and objective nature of reality by making up configuration in addition to the wave function that exists even when unobserved. The many worlds interpretation asserted the objective reality of the universal wave function by suggesting that the wave function describes actual existence, parallel universes, uh, and the multi universes and the multiverses. I'm sorry. Wave function describes, I repeat, wave function describes actual existing parallel universes, the multiverses. Wolfgang Pauli, John von Neumann, and Eugene Wigner suggested that the subjective nature of quantum reality is due to the fact that quantum theory was about mind-matter interactions. Despite all the controversy and the confusion regarding interpretation of quantum physics is the most fundamental physics theory devised so far. Quantum physics provides the most powerful mathematical tool that makes the finest predictions about natural phenomena. Although seemingly very different, classical physics is the special case of quantum physics at the low energy or at the macroscopic level. Quantum physics makes the most accurate prediction about nature. It has expanded our knowledge of nature tremendously in areas such as chemistry, material science, atomic physics, nuclear physics, and particle physics, as well as astrophysics, physics, and cosmology, and more. It has led to significant inventions, including superconductive conducting magnets, light emitting diodes, laser, transistors, semiconductors, such as microprocessor, medical and research imaging such as magnetic resonance imaging and electro microscopy and explanation for many biological and physical phenomena. It opened the door for many important new discoveries in the science, such as the structure of DNA, new fundamental particles, new forces, dark matter, dark energy, and a tremendous amount of new information and the progress in astrophysics and cosmology. The next section is a theory of everything. When quantum physics goes to the subatomic level, it becomes particle physics. Particle physics is a branch of quantum physics that studies the fundamental building blocks of nature. So far, it has discovered that our world is made of 24 elementary particles. The Higgs boson and the four fundamental forces, in parentheses, a strong, weak, electromagnetic, and gravity. These are the four fundamental forces. Except for gravity, these basic elements are classified and explained by the standard model. In the standard model, the strong, weak, electromagnetic interaction are mediated by particles called gauge boson. The different species of gauge bosons are gluon, weak bosons, and photons. The Higgs bosons appear in the standard model to give mass to other particles. Because of its unique function, the Higgs boson is called God, in quotation, is called God particle by some people. Although the standard model represents most of the experimental data well, it does not explain whether matter and forces come from and how they are created. Furthermore, it cannot include gravity in a mathematical consistent way. A more powerful theory is needed. Quantum physics has sparked rapid progress in astrophysics. Astrophysics is the branch of physics that studies the composition and the nature of heavenly bodies, such as sun, extrasolar planets, stars, the interstellar medium, galaxies, and cosmic microwave background. Cosmic microwave background. Our knowledge about these heavenly bodies is increasing quickly with development of more and more detector. In quotation, the more you know, the more you know how little you know, unquote. This applies perfectly in the field of astrophysics. Astrophysicists have found that matter, as we know, it makes up less than 5% of the universe. More than 67% is dark energy. and about 27% is dark matter. Dark energy and dark matter are basically energy and matter that they are not, uh, and that we don't understand and that we cannot describe, other than that they should exist according to experimental data. Current astrophysicists are striving to determine the property of dark energy, dark matter, and black holes, the possibilities of time travel, and the other equally existing topics about outer space. Rapid growth in the astrophysics physics has propelled physical cosmology to a new level. Cosmology is the branch of physics that studies the origin, evolution, large scale structures, dynamics, and ultimate destiny of universe, as well as the scientific laws that governs the universe. Einstein and general relativity provides an excellent mathematical tool to describe and study the large structure of our universe. Quantum physics provides the tool to delve deeply into the planets, stars, galaxies, and universes consist of. Information about our universe is growing exponentially. Much observational data about our universe indicates that our universe started from the Big Bang, followed almost instantaneously by cosmic uh, inflation and expansion of space, from which the universe is thought to have emerged 13.799 billion years ago. However, cosmology has not been able to tell us the source of universe, nor how it has created, evolves, and ends. Quantum physics provides the mathematical framework to unify the strong, weak, and electromagnetic forces, but fail when it tries to include gravity. Although quantum mechanics is not consistent with general relativity, they are definitely not compatible with each other. The search for the theory of everything, in parentheses, is TOE, has been a major goal of 20th and 21st century physicists. Many prominent physicists, including Albert Einstein and Stephen Hawking, have labored for many years to find the theory of everything. Stephen Hawking personally concluded that TOE is not obtainable. String theory is one of the most promising candidates for TOE. String theory studies the quantum dynamic of a string. It is found that the vibration of a string may produce all the particles and the forces observed in nature, including gravity. In string theory, all forces and all matters are naturally unified. However, current string theory is unable to make many testable predictions. Sometimes it's still missing. Something is still missing in a string theory. Many questions remain to be answered before a string theory can become theory of everything. Physics is one of the highest achievements of humanity. As impressive and outstanding as physics is, current physics has two shortcomings. One is that it only deals with material realm. It does not include a spiritual existence. The other is that it does not answer the questions of whether our universe comes, where our universe comes from, how it is created, and how it ends. Whether our a greater unification of all theories is needed, deeper understanding about creation is needed. Tao Science is born. Tao Science. Tao Science is an ancient Chinese word that has many meanings, such as the way, road, course, discipline, method, and more. In this book, we have used Tao to mean the source, the creator, as Lao did in his classic treatise Tao De Jing. Tao Science is the science about creation. It integrates profound Tao wisdom with quantum physics. Tao Science includes three laws. The law of Shang-Chi Jing, the law of karma, second, and the third is the law of yin and yang creation. The law of Shang-Chi Jing addresses the fundamental question of what everything and everyone is made of. This law teaches us that everything and everyone is made of Shang-Chi Jing. Jing is the matter, which is a physical reality we observe. Qi, Q, Jing is spelled Jing, matter, and Qi, spelled here as Qi, is energy, which is our ability to do work. Shen, Shen, includes soul or spirit, heart, and mind. Here, soul is the spirit, heart is a spiritual heart, mind is consciousness. Tao Science gives soul, heart, mind, in parentheses, collectively named Shen, Shen. Scientific and mathematical definition, Shen is information. Information has three aspects of content of information: receiver of information and processor of information, which is correspond to soul, heart, and mind, respectively. This definition makes it possible to study soul, heart, mind, as well as spiritual and conscious phenomena, scientifically and mathematically with quantum physics. In this way, Tao Science brings natural science and spirituality together at the most fundamental level. Understanding the law of Shang-Chi Jing empowers us to gain a deeper and better understandings of ourselves, everyone, and everything, as well as deeper meaning and greater purpose of our lives. It also teaches us what our higher powers are and how to develop and use our higher powers to transform and uplift every aspect of our lives. The law of Shen-Chi Jing also teaches us the profound wisdom and practice about what the highest spiritual state is, the ultimate enlightenment, immortality, bliss, and freedom, and more important, how to reach it. The law of karma reveals scientifically how our current experience is affected by our past actions and how our current actions creates our future reality. It shows us the root cause of everything. The law of karma empowers us to heal and transform every aspect of our lives and become a more powerful creator and manifester. The law of Tao Yin Yang creation is a fundamental law about creation. It reveals how everything and everyone and entire universe are created. From the law of Tao Yin and Yang creation, we can derive string theory, M theory, and all the current physics theory, as well as the ancient Chinese wisdom, including I Ching and the five elements. In parentheses, Wu Xing, W-U, Xing spelled Xing, in parentheses, theory. The law of Tao Yin and Yang creation holds the key to help us reach ultimate enlightenment and freedom. Tao Science is the science about creation. Is to empower us to create the life we truly want. Tao Science is the science of grand unification. It brings grand unification to everyone and everything. Tao Science is the science to attain our higher life potentials and purpose. Tao Science is the science to gain greater abilities and power. Tao Science is the science to reach enlightenment, immortality, and ultimate bliss and freedom. Chapter 3, a law of Shen-Chi Jing. In this chapter, we introduce the first fundamental law of the Tao Science, the law of Shen-Chi Jing. Just to remind you, Shen, S-H-E-N, includes information, content of the information, heart receiver of the information, mind is the processor of the information, and Chi is the energy, and Jing, J-I-N-G, is the matter. It's based on the fundamental, profound ancient Chinese wisdom about what everyone and everything is made of. We will transform modern scientific term to express, uh, we will use modern scientific terms to express and explain this ancient wisdom. As you will learn, the law of Shang-Chi holds the key to unveil the secrets about who we really are, the true purpose and the meaning of our lives, our higher powers and abilities, and how to develop and use these abilities. It unlocks a gate to bridge and integrate natural science and spirituality. It also brings a new approach to explaining quantum physics to lay the person uh, in simple, accessible, and easily comprehended terms. What are we made of? Question mark. Have you ever wondered who we are? What are higher abilities and potentials? What is the deeper meaning and the purpose of our lives? Many of us have asked these questions. Many of us have searched for answer for these questions. To gain deeper insight into these important questions, we need to explore what everyone and everything are made of. Throughout history, there have been many different ideas about what everyone and everything are made of. Natural science tells us we are made of matter and energy. It studies the materialistic nature of our existence. Social science, philosophy, psychology, and spiritual religion ideology states that our essence is spirit and consciousness. They account for the spiritual and conscious aspect of our existence. According to ancient Tao wisdom, everyone and everything is made of Shang-Chi Jing. Jing is a matter, Qi, Qi is energy, Shen includes soul, heart, and mind. Soul is the spirit. Heart includes both the physical heart and spiritual heart. Mind is consciousness. This simple yet profound Tao wisdom is the first law in the Tao Science, the law of Shang-Chi. Law of Shang-Chi. Everyone and everything are made of Shen, in parentheses, soul, heart, mind. Qi is energy, and Jing is matter. The law of Shang-Chi provides the breakthrough insight needed to solve many difficult problems in science. For example, many of us know that the scientists have been trying to reach completely satisfactory understanding of the fundamental nature of reality as presented by the quantum physics. This law yields a new, simple, clear, and profound way to understand and interpret quantum physics in the term of everything everyone can grasp. It paves the way the, to integrate science and spirituality naturally into one at the most fundamental level. It also lays the foundation to drive the grand unification theory. Even more exciting, This law is highly significant for you, me, and all humanity and all beings. It reveals to us our highest self, the much greater potential and the power within each of us, and the deeper meaning and the higher purpose of our lives. Now let's explore of how these come about. What are soul, heart, and mind? To understand the law of Shang-Chi Jing scientifically, we need to give Shen a scientific definition. First, what we are, what are the components of the Shen, soul, heart, mind. Different people, cultures, traditions, ideologies, religions, philosophies, and sciences have different understandings. While attending one of Master Shah's workshop, Dr. Ruling had an aha moment. She saw that it's possible to define soul, heart, mind as physical quantities and calculate them in quantum physics. Consequently, we can understand and study soul, heart, mind, as well as the spiritual and conscious phenomena scientifically and mathematically. This insight eventually led to Tao Science. In Tao Science, the in the in Tao Science, soul, heart, mind, energy, and matter are defined as follows. Soul is the content of information in everyone and everything. Heart includes the physical heart and spiritual heart. A spiritual heart is the receiver of the information in everyone and everything. Every system, every organ, every cell, every DNA, every RNA, and every smallest matter has its spiritual heart. In this book, when we speak of heart, we are generally referring to the spiritual heart. Mind is the processor of the information in everyone and everything. Energy is the ability to do work, such as lifting a weight. Energy is the actioner of everyone and everything. Matter is the physical reality. It is everything we can observe and measure: weight, length, height, charge, mass, electrical field, shape, color, frequency, and the other physical properties and quantities. Matter is the transformer of everyone and everything. In the Tao Science, the manifestation process is soul. Here, let me show you what she wrote. I hope you can see it good. Here, under my finger. Soul leads the heart. Heart leads the mind. And the mind leads energy. And the energy moves the matter. The soul gives a message to a heart, and this is the explanation. Soul gives a message to the heart. Heart receives the message and activates the mind. Mind processes the message and directs the energy. Energy takes action and then moves the matter. Matter is what we experience. Our soul, heart, mind, and energy determines the matter, which is our physical reality. On the other hand, a change in matter can transform our soul, heart, mind, and energy. Therefore, matter is the transformer. Our physical life is to serve our spiritual journey. It is to transform our soul, heart, and mind. Now let's explore in further detail the above definition and the processes. What is the information? We are in the information age. We are dealing with information in every moment and in and every aspect of our lives. Information affects our lives in a profound way. We all know the importance of information. We are familiar with the fact that the information in physical institution and the government records determines our wealth. For instance, a family owns a large piece of land with a big mansion for generations. This family is considered to be wealthy. If one day the information changes and indicates that the land and the mansion are not much worth are not worth much, and this family owes a huge amount of taxes and carries other debts, the family is then financially poor. This shows us that information determines our wealth. Good information is of the highest value. The importance of the information cannot be overestimated. For example, this fact is very clear during a war. One piece of information can save or destroy an entire country. Information is essential for every aspect of our lives. Information can also bring us worry or grief. It can make us sick or healthy. It can enlighten us. It can confuse us. It can bring fortune as well as disaster to our lives. What is the information? Information is the message. It is that which it is that which informs. To inform is to answer a question. Question can be posed so that the answer is either yes or no. Therefore, information can be presented as a sequence of yes or no. A computer specifies information by a series of zeros and ones. The mathematical definition of information is relatively recent development. In the 1920s, scientists at the Bell Labs studying how to improve transmission of information by telegraph found it necessary to define information as a measurable mathematical quantity. Claude Shannon, the founder of information theory, realized that to measure information is to count the number of possibilities. He used bits to measure information. One bit of information refers to two possibilities, yes or no, black or white. and so on. 2 bits of information refers to 4 possibilities. 2 pairs of black or white, or 2 pairs of yes or no. 3 bits of information refers to 8 possibilities. 3 pairs of yes and no. For instance, a coin has 2 sides. If you put one coin on the table, there are 2 possible images. In mathematics, we say there are 2 possibilities. 2 in square root of 1. You need 1 piece of information to determine the state of the coin. If you place 2 coins on the table, there are 4 possible states, 4 possibilities. 2 in square root of 2. You need 2 pieces of information to determine the state of 2 coins. In general case, Shannon found the measure of information relates to entropy, discovered in the thermodynamic. Entropy measures the possible states in a system. Specifically, it measures disorders. Disorder is the existence of unrelated possible states. A fundamental discovery in thermodynamics is that heat, which is one form of energy, increases with entropy and temperature. This tells us that information can directly create energy. Heat is the energy created by information. Matter and energy can be processed, transported, manipulated, and transmitted. So can information. Living in the information age, most of us are familiar with the processing, transmitting, downloading, moving, transferring information. Computers and the internet are technology that makes it easy for us to process, transfer, transmit, move, and download information. It has become an important part of our lives. Our world, everyone, and everything are made of matter, energy, and information. Matter, energy, and information coexist in everyone and everything. There is no matter that does not carry information and energy. Similarly, there is no energy that does not carry matter and information. And there is no information that is not carried by matter and energy. Matter and energy are the carriers of message or information. Matter, energy, and information are the 3 basic elements of everyone and everything. We suggest that Shen is information, energy, Qi is the energy, Jing is the matter. The law of Shang-Chi Jing is also can be expressed as everyone and everything are made of information, Shen, energy, Qi, and matter, Jing. Soul, heart, mind are 3 aspects of information. The content of information, the receiver of information, and the processor of information. Quantum physics of Shang-Chi Jing. Quantum physics is a science that currently reveals at the deepest level what everyone and everything is made of and how they behave. What can quantum physics tell us about our soul, heart, mind, energy, and matter? The quantum world is intriguing, magical, and empowering. We will also see how the law of Shang-Chi Jing can shed light on some challenging problems in quantum physics. Imagine now that you are quantum physicist. You have a powerful microscope. You are going to use this microscope to find out what everyone and everything is made of and how they work at the smallest scale. You look at your body under microscope. You find that although different parts of your body look different, they are all essentially the same in the sense that they are all made of cells. Now you adjust your microscope and look at the cells. You find that although there are many kinds of cells, all cells are made of molecules. Now you adjust your microscope and then look at the molecules. You find that although there are many kinds of molecules, all molecules are made of atoms. Now you adjust your microscope and then look at the atoms. You find that although there are many kinds of atoms, all atoms are made of nucleuses and electrons. Now, because your microscope is so powerful, you can adjust your microscope and then look at the nucleus. You find that the nucleus is made of protons and neutrons. In real life, no existing microscope is powerful enough to see what's going on inside a nucleus. Particle physicists study the nucleus by using accelerator to produce particles with high energy. They bump, in quotation, they bump the nucleus with these high energy particles and then observe what is produced by bumping. From these analyses, they have found that the nucleus is made of protons and the neutrons. In the same way, they study what protons and neutrons are made of. Through long and difficult experiments and the mathematical deduction, they have found that protons and neutrons are made of quarks and gluon. Now you look at quarks, electrons, gluons, and the photons. You found that they seem to be complete. You cannot break them down further. They are the basic building blocks for our world. Quantum physicists call them elementary particles. To your amazement, although these elementary particles have energy, charge, spin, even mass, they don't behave like particles at all. They all behave like a wave. Wave is also called vibration. Vibration or wave is a periodic oscillation. Wave is characterized characterized by its wavelength, frequency, and amplitude. Wavelength is the distance between the successive crests of the wave. Is the distance between two adjacent waves. Frequency is the number of occurrences of repeating oscillation per second. Let me show you this figure so you can see what I'm talking about. I hope you can read it good. Okay, and per second, frequency measures how quickly a wave oscillation uh, wave oscillates. Period measures between the two waves. Period measures the time it takes a wave to oscillate from one wave to a complete cycle. Amplitude is the measures the height of the wave. A wave is constantly moving. When a wave moves, it carries matter, energy, and information to different places. Velocity measures how fast a wave travels. The following diagram, as I showed you, illustrate the wavelength, frequency, amplitude, and the velocity of a wave. Now let me show you again. Okay. Now let's sit at the beautiful beach in Hawaii and watch the ocean waves. You can jump into the ocean and then let the waves carry you up and down. You can surf the waves and then let the waves move you forward. You can simply watch the waves and surfers. Seeing the excitement and accelerations of a surfer catching and riding the waves. Observe the ocean waves closely. Unlike a stationary object, waves never stay still in one location. They constantly oscillate. They travel. The ocean waves oscillate going up and down. They travel, splashing at the shore. They move from one place to another. They exist in the whole ocean. In the same way, a quantum wave constantly oscillates, moves like ocean waves. Quantum waves exist in all space and time. Now look at the waves, ocean waves more closely. You will find there are all kinds of waves in the ocean. There are long waves and the short waves. There are tall waves and the low waves. Like the ocean, everyone and everything does not usually contains only one wave. They contain many waves. Everyone and everything is basically a vibrational field containing many kinds of waves like an ocean. However, a quantum wave differs from an ocean wave in two ways. An ocean wave is carried by ocean water. A quantum wave does not need a medium like an ocean water to carry it. A quantum wave exists on its own accord. Quantum waves are the fundamental building blocks of everything and everyone. Every vibrational field carries information, energy, and matter. The energy and the momentum